And we should be live.
Hello, everyone.
Are we live? Yeah.
No response.
Yes, we should be live.
Yeah, so hello everyone. Welcome to our Angular joint meetup. Together, we join forces with three Angular meetups: Angular Athens meetup, Angular Dutch, and Angular Birmingham. I'm Aristides. I'm from Angular Athens, and today we have some special guests. We have some guests from the Angular team that will talk about the latest news of Angular 12. So stay tuned, and Yanis will tell us about what's coming.
Yeah, so stay tuned, everyone. Starting off, we have Minko Gechev from the Angular team with the first speech about Angular 12. Minko, take it away.
Sure. All right. Hello, everyone. My name is Minko Gechev. I'm working on Angular at Google. Today in this presentation, I would want to share with you what is the current state of Angular. We're going to discuss what is the position of Angular within Google, what is its community adoption right now. We'll be talking about some community highlights, community projects that were developed over the past couple of months. Right after that, we're going to move to the latest feature that we introduced as part of Angular version 12. And finally, I would want to share some major efforts that we have been involved in order to make sure that we respond to community feature requests and address all the pull requests and fantastic contributions that we've been getting from folks. So we've been talking a lot about how Google supports Angular, but we haven't been talking about the other side of things. We haven't been talking about how Angular supports Google. And pretty much Google runs on Angular. So if you are an engineer or if you're at any position literally at Google, in order to interact with your colleagues, you will be using our issue tracking system in order to file a bug. It is called Buganizer. If you want to look up source code in our monorepo, which has a couple of billions of lines of code, you will be using a UI that is developed with Angular. This is our code search UI that is actually available also online. It is open source. If you want to open a text, just a file, edit the file and submit it for review afterwards, you'll be interacting with a text editor that is implemented in Angular. And finally, if you open a CL, or that is our change list or pull request, if you prefer to use the Git terminology, you'll be interacting with a code review system that is implemented in Angular as well. And these are just 4 examples of the thousands of projects that are developed in Angular within Google. Many of them are small apps, just cafeteria applications. Some of them are mission-critical applications that are part of your critical workflow, and others are large public-facing apps, including the Google Cloud Console, which is probably one of the biggest Angular applications out there. It has at least 2 million lines of code as of today. We also have Firebase Console, Google Domains, Google Analytics, and many others. On these applications, there are quite a few people who are working on them. In fact, we have thousands of engineers who are altering Angular code monthly. This is based on statistics which we're getting from our monorepository and how many people are submitting CLs using particular technologies. And there are about 1,000 engineers who are taking our internal Angular course. We have a couple of internal Angular courses, Angular 101 and Angular 201. And we have been teaching folks on how they can use the framework into the context of the Google's infrastructure. So a good question is, why is even Angular open source? Because Google has been extracting a lot of values in different ways by using the technology internally. Why even bother supporting it as an open source tech stack? Well, there are a lot of values that we're getting for both like Google, the framework, and the community out of this. First of all, hiring. If people are familiar with Angular, if they're already able to use the technology, they will be productive much faster if they joined Google, because Google is using Angular actively, and people who are familiar with the basics of Angular, they will be able to quickly ramp up with the Google infrastructure. The ecosystem is a huge benefit. There are thousands of people. Well, I was originally involved in the ecosystem. I mean, I'm still involved since like 12, I would say. I've been contributing to the Angular ecosystem in different ways as an external contributor mostly. And all these contributions are applicable not only within Google, but also in all other enterprises and small companies. You can reuse all this content that is available online, or use all these fantastic open source libraries that are distributed on NPM. The feedback that we have been getting is fantastic. We have, if you look at the number of issues we have on Angular, actually there are a bunch of them are feature requests. So we've been getting a lot of feedback and a lot of feature requests that are helping us determine the future of Angular. We have been getting a lot of bug reports that are making us make Angular a better technology for everyone as well. And clearly, quality. There are hundreds of thousands of people looking at the Angular source code. And if there is something wrong, we're usually getting pull requests. So when you have hundreds of thousands of eyes looking at your code, it ultimately becomes better over time. Now I would want to spend some time talking particularly about the ecosystem, because I feel also particularly connected to it, given that I've been contributing to Angular before I joined the team for about 6 years in different capacities. I've been pushing calls to just opening pull requests, building open source libraries, writing blog posts, giving talks. It has been always a lot of fun. So the adoption in the open source community that we observed over the past 6 months is as follows. We saw that the number of NPM downloads grew from about 1.5 million a week to 2.5 million. And we currently have over 1.8 million open source projects on GitHub that are dependent on the framework. These are only open source projects. I'm ignoring all the different production applications which are probably in private repos or they're hosted in other platforms. These are only the GitHub projects that are dependent on Angular core. And some of these projects are pretty interesting. Like, I couldn't possibly take a look at all of them, but some of them that I'm familiar with are, for example, the Spotify clone by Trang Vo, who he implemented, and it is a full-fledged Spotify client that you can use in order to listen to music and also have these fancy visualizations. It is not only useful, but also it is open source. So if you want to look at more advanced Angular concepts, if you want to see how you can build a real life application, if you're just getting started with the framework, this will be a fantastic example. It has been also a pleasure collaborating with Christoph. Christoph is a researcher from Harvard. He was working on finding an antiviral for COVID-19. Christoph's team, they were using Angular for visualizing different molecules. So they were pretty much trying to find specific molecules that can bind to your cells and to the virus so that they prevent the virus from binding to your body cells, and this way eventually to help you prevent getting COVID-19. They were using Angular for their visualizations, for their user interface, and this was one of my highlights for 2020, having the chance to collaborate with them. And there are many folks who are also building just better infrastructure for Angular, and they're doing it as part of their spare time. For example, Manfred. Micro frontends, it is one of the probably most trending topics right now, especially for large enterprises who wants to build scalable applications and who wants to be able to deploy them independently and build them without having to wait for hours. Because at a certain point, it doesn't matter how fast your build is. When your source code is several millions of lines of code, well, eventually your build is going to get out of memory. So the solution there is usually to decompose your application to smaller apps and use something like module federation or micro frontends. We have been also collaborating with Yadong and with Leon in order to implement an image component that helps with largest contentful paint and is optimized for Core Web Vitals. Now, talking about Core Web Vitals, we have been closely working, we have been actually part of the Web SDK initiative at Chrome. The Web SDK initiative at Chrome is aiming to enhance the Core Web Vitals metrics for popular frameworks out there. This includes Angular, it includes like Next.js, even Next. We have been talking to these teams as well in order to make sure that we're performing well for largest contentful paint, first input delay, and also cumulative layout shift. As part of these efforts, the primary goal, I guess, there is to make sure that we're providing good user experience and also since they're part of the search ranking algorithm, they're pretty critical for your SEO friendliness as well. For example, we collaborated with the Chrome metrics teams on the implementation of largest contentful paint. We gave them feedback about some potential issues that folks can face with Angular and other alternative technologies. And we worked together on the implementation to make sure that we have a consistent metric that is applicable across the board. A couple of the optimizations that we implemented together are related to inline of Google fonts and also extraction and inline of critical CSS, which is now enabled by default as part of Angular version 12. If you want to learn more about the SEO friendliness of Angular, I would recommend you to have a look at this case study by Crunchbase, who are serving over 1 million users weekly, and 70% of their traffic is organic. And it's interesting what their motivation was for moving from their Rails stack to Angular. Some of their pages were taking 20 seconds to serve, and now with Angular and Angular Universal, they dropped to 150 milliseconds. All right, now let's talk about what is new in Angular version 12. A couple of the highlights on high level are first, keeping track with the modern standards and simplifying the framework. This has been from a high priority for us, specifically because we want to keep Angular to be evergreen. So we want to make sure that we're keeping up with the latest web standards and we're helping everyone move along with them as well. Simplification is another part of the story where we're trying to get rid of things that are no longer applicable and no longer relevant for us. We want to deprecate things as soon as possible. We want to be able to get rid of legacy code so that this is not a maintenance burden and also doesn't impact the application's performance. And also we had a couple of feature drops, and we introduced a new tool last week that I'll talk about. So modern standards and simplification. We deprecated Internet Explorer 11. We run a community RFC, and we collected a lot of feedback from folks. Over 95% of people were very excited that we will no longer be supporting IE 11. So we will be able to take advantage of new standards, such as, let's say, CSS variables. IE 11 was the latest non-evergreen browser that we supported, and yeah, we're happy to be able to move forward from this. Also, we deprecated View Engine. If you're familiar, we have kind of two rendering engines and compilation pipelines that we're maintaining in parallel right now. We have View Engine and we have Ivy. Yoast will be talking more about Ivy and how we are managing our library distribution there in the next talk. So with the View Engine's deprecation, we are getting rid of large chunk of code that we no longer have to support and maintain, and we're moving forward to enable more Ivy-specific features over time. Specifically, I want to talk a little about the deprecation of View Engine. We enabled Ivy by default in version 9, and it has been a default experience since then. But we also provided a flag that allows to opt out of Ivy, called enable Ivy, that you can set to false. And we noticed that almost nobody was using this flag and setting it to false in version 11. There were maybe a couple of folks who maybe did it because they were following old tutorials. So we saw that the ecosystem is already feeling comfortable using Ivy for building their applications, and we move forward with our process for moving libraries to Ivy as well. First, for applications, we removed the option for using View Engine. This means that your Ivy applications, they would continue working with View Engine libraries and with Ivy libraries as well. Specifically with View Engine, they'll be working with our Angular compatibility compiler, or NGCC. For libraries, in version 12, we enabled the stable Ivy library distribution, which means that over time, you will be seeing fewer NGCC runs for libraries that you're using as part of your application, because they'll be just distributed with partially compiled format that is Ivy first. Now let us talk a little bit about feature drops. We have this concept of feature drops where just by running ng update, you get a couple of new features after every release. Some of the features that we enabled prior even to version 12 that are now some of them enabled by default are, for example, Webpack version 5. this is now the default experience for folks who are running Angular version 12. And I think over time, you'll be getting more and more benefits from Webpack 5. Currently, for example, we have no disk caching because this is not enabled by default for Webpack by itself. But over time, when this experience gets more stable, we'll be able to adopt it in Angular as well and hopefully help you have faster builds. Now the language service is using the Ivy compiler in the backend by default so that it can use it, actually it's on the front end, to parse your source code and provide diagnostics. We also have better error messages. We worked on developing guides and videos with partnership with Farship.io in order to record different videos for the top most common error messages and add links inline in the run and compile time errors themselves. We worked on resource inlining, as I already mentioned, inlining of critical CSS and also Google Fonts. And we introduced Tailwind support. That was another effort where we run a community survey on Twitter, and we saw that over 90% of people wanted just to use Tailwind as their post-CSS plugin. So we decided to add native support in the Angular CLI for it. Now, the Angular CLI as part of your build process is going to check whether you have Tailwind installed and whether you have configuration. And if you do, it is going to just trigger the post-CSS, the corresponding post-CSS plugin. Now, let me talk about some Angular v12 features specifically. So first, inline Sass. For a while, we didn't really support transformations of inline styles. So if you want to use post-CSS or Sass as inline styles, this wouldn't have been possible. However, as part of version 12, we introduced this transformation pipeline for inline styles as well, which brings us higher level of consistency. We added knowledge coalescing support in templates. If you remember, knowledge coalescing is this ECMAScript feature that was, I believe, introduced last year together with optional chaining. And we have been having kind of a slight variation of optional chaining for a while. We were calling it the safe navigation operator in Angular templates. Now we have knowledge coalescing as well. And over time, we're going to adjust also the semantics of our safe navigation to align better with optional chaining. We have production build by default. This is a feature that we have been considering for a while. It's just mostly to make sure that people are not accidentally deploying their development builds, which is something that we have unfortunately seen far too frequently. And also to ensure better interoperability with infrastructure, like with deployment partners, such as, let's say, Vercel, Netlify, Firebase, and so on and so forth. We have strict mode. And also, we're updating our end-to-end testing strategy based on the community feedback we received in our protractor deprecation RFC. So the protractors feature is still not completely determined. This is up to be resolved. But at the same time, we started working with partners such as Cypress, Test Cafe, and also WebDriver.io in order to ensure that they have good integration with the Angular CLI and they're providing builders that you can use for your ng-e2e command. A couple of community highlights. We have been receiving a lot of pull requests. I'm going to specifically mention the numbers at the end of the presentation, but some of the highlights, some of the most popular features that community implemented was adding HTTP request metadata that is now available in interceptors. We also added Sonu added min and max validators in forms. So you just need to specify the min and max attributes. And from there, you're going to get form validation behavior for input type number. Mike added a meet event option for abstract control. So I guess all the different concrete implementations of the abstract control are going to have this method now. And Yadong added app initializer as an observable. So now you can run some logic before your application actually bootstraps, and you can notify your application with an observable that this execution of the initialization logic has completed. And also new tooling. This is something that we introduced last week as part of Google I/O. We have been working on development tooling for Angular for a while now, and specifically on a Ivy-specific Ivy implementation of Augury, which provides a slightly different set of features. So we teamed up with Rango.io, the original developers of Augury, which was our Chrome DevTools extension. And we developed Angular DevTools that is now available at angular.io/devtools. It provides the same component explorer where you can see the nesting of your component tree. You can explore the inputs, outputs, and properties of the individual components. And it also adds a profiling functionality where you can pretty much preview the execution of your change detection in real time just by interacting with your app. And for each individual change detection cycle, you can preview how much time you spent in the individual components. Yeah, we're happy to be able to share this finally with everyone. Over the first 3 days, the extension got 20,000 installs. So we're happy to see this fast adoption from folks. Looks like this was highly needed. And last but not least, I want to just thank first to everyone who has opened a pull request to Angular. I was looking at the pull request numbers recently, and we have over 18,000 pull requests that have been opened to the Angular framework repository, to Angular. That's a large number of PRs, and a big chunk of them are from community, from team members, but also a lot of them are from just community members who spent some time in their, they took some of their spare time in order to make Angular better. We're doing our best to merge as many of them as possible, and currently we have fewer than 256 open pull requests. At a certain point, we had fewer than 200, we will be happy to continue this process triaging and helping folks get their work in framework. Thank you very much for listening to me. I would really appreciate your feedback about my talk on mgv.io/talk. And that's all I had for you. I would love to answer your questions at the end of the event.
Thanks a lot, Minko, for great updates, and also pretty interesting to see these statistics. Is pretty nice to see. Continuing, let's give the floor to Joost Koehoorn. I hope I said this properly, and please take it away.
Yeah, you did great. It was one of the best pronunciations of my name since a long time. I was not meant to press share. Yeah, so hello everyone. Good evening, I presume, for most of us. I will be talking about Angular libraries tonight. So first, a bit about me. I live in Utrecht, which is in the Netherlands, which has this famous Dom building you see on the right. And I've been using Angular since the summer of 2017. And soon after that, I became involved in Angular's GitHub repo, similar to how Minko got involved in Angular itself. And from there, well, it basically escalated into me now working on the Angular compiler a year after I even started doing any Angular stuff. And I've been part of the team for, about 2 years now, where I've been contributing to mostly the compiler still. That's what I like most. And today, let's take the opportunity to look at Angular libraries in more detail. And I wanted to first start just by introducing what libraries are and how you can use them before getting into some of the technical details of how this stuff works. And also what's changing in Angular 12. Minko already mentioned that we introduced some new stuff in V12, and one of the things was entirely around library support. And I'll be showing you what this entails and how you can start using that as well if you are already building libraries. So without further ado, let's get into the introduction of libraries in the first place. And you may wonder, what are libraries and why should I use them? And generally speaking, libraries allow you to reuse code and bundle specific code into a neat little package. And this may be that you use libraries from other companies or that are just available on NPM, for instance. That's typically how you interact with libraries. But it could also be beneficial to build your own libraries in-house. For instance, if you have a design system of some sort, then it makes sense to develop and maintain that in a single library and then distribute that across all of your internal projects. And then it doesn't even need to end up on NPM. And what this achieves is really a nice separation of concerns. So it's nice to have this, for instance, design component system neatly packed away somewhere where you can make changes to the design system separately from all of the rest of your applications that you host in your company, for example. And then also, Minko also mentioned briefly that at some point you end up with such large applications and compilation units that it becomes unmanageable in terms of resource usage. So think about memory usage, for instance. And at this point, it becomes also logical to split up your applications into multiple pieces. And libraries can help in this area because separating stuff out into libraries enables building the libraries, which are that smaller, of course, than if it were all combined into a single app, to build them separately and then publish them, for instance, to NPM or to another private artifactory, or even just store them in a mono repo, but still treat them as separate libraries. This enables like smaller builds because, well, as I said, the libraries would have already been compiled elsewhere. So that's basically the gist of libraries and how they can be beneficial to your project. And creating libraries is actually fairly simple in Angular using the CLI. Because it has built-in support for dealing with libraries as such. So if you have the CLI installed, you can just do ng-new and then the name of your workspace. And it is possible to create a workspace only for a library. So if you intend to only host a library in this workspace, then you can pass the create application equals false flag to ng-new, and then it will only create basically an empty workspace. So after CDing into that directory that it created, you will have access to this empty workspace, and you can then generate a library. And again, you can choose any name you want here. Although if you do plan to publish it to NPM, you might want to consider, or actually choosing a name that's still available and that you intend to ship to NPM, because this is not something you can change if you end up publishing to NPM. Or at least you cannot easily change such a thing because all of your consumers depend on that name. And then for example, I'm building the library immediately afterwards here, and that will generate basically an empty thing because we haven't done anything yet. But at least this is kind of the structure that you get that is created. So in the file bar, you see that in the projects directory in your workspace, you now have this library project, ng-awesome in this case. And it has a source directory and also some various files to support all of the various things that are in this library. And one of the things that I highlighted here is the ng-package.json file. And this is basically the specification of how your Angular library is bundled together, where you specify an entry file, which is the single entry point of your library. And you can include more stuff there, but that's stuff I omitted for here. This is the simplest thing you can do, and it works out of the box. Also, there's a package.json file here. And this package.json file is what ends up as on NPM as well, if you do publish to NPM. So this specifies like the name of your library and also all of its dependencies and peer dependencies that it has. And then the various tsconfig files specify how to compile this TypeScript files into your into the final JavaScript bundle. And this is what's generated by default. You can then, of course, remove all of the default files and start from scratch. or you can edit them as you wish. And when building a library, it's always important to think about how your consumers of the library will interact with it. So you have to think about defining a public API for your library. And what I mean by that is that you have your JavaScript or your TypeScript modules, which export classes and functions and variables and stuff. But it may be that you don't want to actually expose all of these implementation details also to the outside world, because then you can't easily change all your stuff or move stuff around, etc. So in that case, it becomes important to think about what you do want to expose and the names that you choose, for instance, for all of these things. Because as I said, you don't want to expose probably every implementation detail that is hidden in your library, or at least you want to keep it hidden. And this is where the public API file comes into play, which is basically a single file that exports all of the things from across your library that you intend to let your users also refer to and use in the library. And you can see here you can use export star to basically export everything that is available in a single module. But you can also be more explicit and list out the specific symbols that you want to export from certain files. So that allows you to have, to declare multiple classes or multiple functions in a single module if you think that's useful, and then only export a few of them. And you can even use export as syntax, where you rename a symbol such that a consumer of your library will have a different name than what is internally used. And before I continue, I wanted to first go over a bit of terminology that is typically used when dealing with libraries. And some of these are used interchangeably quite a lot, and it's important to know kind of what the difference is and where the distinction lies. So until now, I've talked about libraries, and that's basically just the concept where you define a reusable collection of code into some sort of unit. And typically the unit is a package where that's the thing that ends up on npm, like a single directory in node modules with a single package JSON file. So that's a package, and I have to say that libraries and packages are basically interchangeable, those terms. And then, especially in for Angular libraries, it's typical to also have the concept of entry points, which are separate units within such a package, where a package can have one or more entry points. And we'll see an example of that later. And the primary entry point within a package is just imported using the package's name itself. But then you can also have additional entry points that have different import paths for your library. And what it looks like, well, or basically how you can use that is to split unrelated areas that still kind of belong into the same library or package into smaller compilation units, because each and every entry point is compiled separately from the rest of the package. And an example of this is how Angular Common has both Angular Common itself, that's the primary entry point, and then also the HTTP module and stuff, which is all implemented in a separate entry point, and it's imported therefore also from a separate module specifier in applications. And you can do this so in this design, HTTP kind of belongs in Angular Common because it's typical to have, and this was a natural layout for us to choose. But we didn't want to conflate it with the regular stuff that's already in Angular Common, so that's why it's split out into its own entry point. And each and every secondary entry point also needs to have a package JSON file because it TypeScript, for instance, uses this package.json file to refer to other files in the secondary input entry point, but those particular files are not actually used by npm. That's something to be aware of sometimes. That can be confusing. And then what you also need to do when you start using secondary entry points is that you need to set up your path mappings. By default, you'll get the path mapping, the first one that's shown here. But if you start adding secondary entry points, then you can see that the ngAwesome example that I show here would not match any of the secondary entry points that you define. So that's why also the secondary entry points have to be defined explicitly here, like this, where you map a certain module name into a location on disk where it is able to find it. And notice in this case that it's using that it is mapping a module specifier, ngAwesome and ngAwesome/testing, into the dist directory on the file system. And this means that any of your application consumers that use these module specifiers will also end up in the dist directory, which basically means that they will interact with your library exactly like any other consumer, for instance, after shipping to npm, will also interact with your library. This does, however, mean that you need to build your library before you're actually able to use it. But it's the most true to what will eventually be the workflow for other folks. So that's recommended from the Angular CLI perspective to do it like this. And this, by the way, happens to be added to the tsconfig.json file in the root, because if you do it there, it will also be picked up by IDEs, and these will help with import suggestions, for example. Oh, well, this doesn't fit. It should have been on a single line. But then you have this library somewhere, you have, in this case, 2 entry points, and you want to start using this library from an application. And the way to do that is just to start importing from it, basically. And you see here that the primary entry point is just imported using the package name itself, and then the secondary entry point has this /testing suffix behind it, which was the entry point's name. And from here you can refer to all of the stuff that has been exported from the public API export file that I mentioned earlier. And to expand on those import and export rules, it's good to know that there are, well, like I said, there are certain rules that are nice to be aware of and easy to get wrong, to be honest, where entry points can import other entry points within the same package. But if they do that, they have to use their absolute module name. And this also means that you can't import from one entry point into the other and vice versa, because then you create a cyclic dependency and you can no longer build your library in that case, because, well, the output of the one depends on the output of the other, which depends on the output of the third. So then you get yourself into a loop, and that's not supported. But when you get to importing within an entry point, then you start to, well, then you actually need to use relative paths. Because otherwise you would be importing yourself, basically, if you were using its module name instead. And importing itself is also not supported, because then you have kind of a cyclic dependency on yourself. And these are easy to get wrong, but it's nice to adhere these rules, because they end up being a lot more friendly for your tooling to understand your intention of how your library is structured. And then I have to think what this says. I don't know anymore. Well, I might get back to this. I have a brain freeze, I think. So one other thing to add on top of the import structure is that you should avoid deep imports. So as I mentioned before, your library contains some modules, some JavaScript modules. And normally you can import such modules using import and export syntax. But if you are behind a library, if you're implementing stuff in a library, you don't want to import directly all of these individual files, but you want to go through the public API service of that library. And that's why it's generally better to avoid deep imports and only target the public API file. Because this helps in restructuring the library's internals down the line. So you're not tied to a specific file structure there, and that's very useful. And there's another aspect that when you build your library and actually publish it for NPM, for instance, then there's a process called flattening, which take all of the individual modules that you authored in your library and bundles them into a single file. And it's not like Webpack bundling, but it's more like just concatenating all of the symbols into a single file. And now you see that if you would have used deep imports, then those can't refer to this flattened file because the deep files that are imported actually don't exist in this format. And then users of your application should therefore always use the module name of the public API file and not any of the actual modules within the library. So that was basically a rough overview and a quick overview of what libraries are and how you can use them in the CLI, and a bit of the rules on authoring libraries. But I also wanted to get into the technical details of how this works behind the scenes and what it means for the compilation of a library, how that all works. And to understand better what's going on, we first need to actually talk about how Angular libraries are special in some sort. And we have been meaning to make them less special, especially in Angular 12, and I'll get to that in a bit. But if you think about it, you'll notice that Angular directives and Angular components have to be compiled at some point, especially your template that you author have to be rendered by Angular at some point. And in order to do that, it needs a compiled output of that template to be executed in the browser. But then when you build a library, that library also needs to support future versions of Angular. Because I don't want to consistently repackage my library whenever a new version of Angular is produced. So I want to build a library today and then hopefully still be able to use it next year, for instance. And that means that you can't compile it ahead of time like you normally would with application builds. Because if I compile it today using the AOT compilation mode that you regularly use in Angular, then you will also use the output of today's Angular runtime. But today's Angular runtime may not be how the runtime looks like in Angular 14, for example. So we can't quite use the same strategy here that you're used to from application builds. And the way that the Vue engine or the old compiler basically solved this problem is that it would ship a special file alongside your JavaScript modules when publishing a library. And these were the metadata.json files. And this file is basically a description of all of the source code that was originally written. Let's go back. And it describes, like I said, all of the classes and the methods that are available and all of the decorators that are in there. And this information can then be used when consuming such a library during an application build. So this can be shipped to NPM, and then next year, for instance, I can use this file with another version of Angular, where the compiler is able to read this metadata.json and recognize all of the decorators because they are specified in that file. And using all of the information in that file, it is then able to compile the library in the context of your application. So it also uses the exact same version as the application uses. But this file was kind of special, and it was kind of a special Angular thing that was in there. And for our tooling to understand and reason about these, or actually be able to find these files, there had to be some sort of a packaging convention. And this is where the Angular package format comes in, which implements, or basically is a specification for how Angular packages should be built and bundled for publishing to NPM. Where the file structure, for instance, is specified, and this is important because that allows the compiler to know where to search for all of these metadata files. At least that's how it used to work in Vue Engine. It also governs the various JavaScript module formats, because the JavaScript ecosystem is constantly changing and evolving from older standards into newer standards, where it used to be ES5, for instance, or UMD bundles, whereas it's now more common to use ES 2015 with certain, or basically with the ECMAScript module format that with the import and export statements. And tooling needs to know kind of what kind of format it's dealing with in order to optimize your library builds and application builds most effectively. And this is all specified in the Angular package format. And currently what it does is it bundles ESM 2015, which is ECMAScript modules. So that's the import and export statements using the ES 2015 language syntax. So that allows you to use stuff like classes and things. Then there's also the FASM, which is basically identical to ESM, but then it's the flattened variant. So that's where the F comes from, which is all of the files concatenated into a single bundle. And then there's also UMD, which is Universal Module Definition, I believe. And that is shipping ES5 code. And all of these are contained within an Angular package format. And like I said, this is all done in order for tooling to best understand what's going on and to use your library as effectively as possible. And fortunately, you don't have to know anything about this because typically this is dealt with by tooling. And the typical tool for this is ngpackager, which is an open source tool which you can find on GitHub. And luckily, also additionally, this has very good support from the CLI. So what I shown earlier with ngGenerate library, for example, that uses ngpackager behind the scenes to make it all work. So you don't have to actually get into how ngpackager itself works, for the most part. So then let's get back to how Vue Engine then builds an application where it finds, oh, I already went through this, where it finds all these metadata.json files and then compiles your library alongside an application build. And that's actually fairly wasteful or expensive, at least, because libraries change far less often than your application rebuilds. Mostly, you don't have to recompile Angular core, for instance, or Angular common of all of Angular material during every build, because you download it from npm once, and then you start developing your app. And you don't need to recompile all of Angular material because it wouldn't have changed. But the way that Vue Engine worked would still require every library to be compiled for the Angular runtime when your application was built, because it was all a single unit. This is something that the Ivy compiler and the Ivy Angular Ivy wanted to tackle and wanted to address. So what we've changed is that instead of generating this proprietary metadata.json file that our compiler understood, we now leverage the TypeScript declaration files that are well known across the industry, where we specify all of the Angular metadata that the compiler eventually needs. We specify that, and that needs to be visible to other basically upstream applications. We specify that in the declaration files, and this is, for instance, an ng module lists all of the declarations and all of the exports that it has, because then an application knows that, oh, I know that ng4auth comes from common module from this declaration file. That's basically how you can think about it. And then the JavaScript files contain a form of compilation that's not the final form, but it is appropriate for a step that is executed when you npm install, for instance, that transform it into the final code according to the version of Angular that the application uses. And that means that Ivy doesn't use any of the metadata files that used to be used by View Engine at all anymore. So instead, it uses all of these declaration files to do the work and to understand kind of what is inside of a library without actually looking inside of the source code of the library. And what it means for us is that APF doesn't have to be as complex anymore, because now the Angular compiler just really leverages the regular TypeScript ecosystem of having these declaration files around, instead of building on top its own kind of definition structure that needed to be dealt with before. So this was actually a simplification that we wanted to achieve with this new format. And then starting from V12, we now also allow your libraries to be compiled natively for Ivy. So as Minko mentioned earlier, we started to enable Ivy in version 9 of Angular, but then it wasn't ready for also shipping your libraries using the Ivy compilation format, because we weren't ready for that yet. So we had to continue using the View Engine compiler with its metadata system to build libraries. And then the Angular compatibility compiler would convert them to be compatible for Ivy in your application. But now in V12, we are finally ready and have a new way of compiling libraries that's all based on the Ivy compiler and Ivy ecosystem. So that's great. And I wanted to show how that kind of works. So consider this example where you have a very simple template, and it uses ng4, and it also uses a different component from the library. It's order item in this case. And when you compile this, or when you build the library, the compiler will recognize this decorator and will convert it into a partial declaration. And this is new in Ivy. And this partial declaration contains all of the metadata that is necessary for eventually compiling that component, but still a very readable format. And we can keep this we can consider this as a stable format, and therefore it's suitable for npm, which means that I can publish this today and then expect the Angular compiler to be able to recognize this still in a year in Angular 14, for example. And that's also why you see stuff like min version in here, where this partial declaration tells the compiler that it needs at least Angular 12 to work, basically. There's also an ng import property in here that's this part, and that specifies, or that can be used for us when we eventually compile it to refer to all of the things that are in Angular core. That's what the ng variable exposes to us. And then following that is like the original metadata that was specified in the decorator. But on top of that, we now also specify the information that was coming from the ng module side of this component. So that's where the order item component, for instance, it came from an ng module that was defined somewhere in the application. But now we are coalescing all of this information, gathering all of this information together into the partial compilation so that we no longer have to consider where the ng module was. It might have been in a different file. But by grouping it all together, we can compile this partial declaration into its final AOT output just by looking at this single call site, which is very powerful. And this is where the Angular linker there comes in. So what you saw just now is the format that ends up on NPM, and it can sit there for a year, and then someone comes along and wants to actually use this library. So he downloads it from NPM, and at that point, the Angular linker is able to transform that code with the partial declarations into fully compiled code according to the version of Angular that is used at that point. So that could be version 14, for example. And we implement this Angular linker using a Babel transform. So Babel is a tool that runs probably runs in every JavaScript build around the globe. That's how popular it is. And it transforms the JavaScript file into basically a different JavaScript file, where, for instance, async await is now using the ES5 syntax. That's what Babel is capable of doing. And just like that, we've also implemented a transform that is able to recognize these partial declarations and then compile them into fully AOT compiled Angular code. And what we get from this is that it can operate on individual source files. And then this enables, for instance, efficient caching, because if the source file itself didn't change, then we also don't need to run this Babel transform again. And that makes it a lot more efficient compared to the metadata.json system that the View Engine compiler used, because that really needed to compile all of the libraries when the application itself was built. But because now everything just happens using the individual source files, it can be much more efficient because we can cache all of these actions. So let's go back to the example to see what it means. I have this code, it came from NPM in this case, and the linker runs through this file and sees that there's this partial declaration ng-declare component call somewhere in the file. And then it takes that object literal that it is passed and extracts all of the information from it. And all of that information is then fed into the Angular compiler to finalize the compilation and to convert it into defined component. And that's where you now start to see your template function with all of the instructions, or all of the IV instructions that you may have seen before. So that's basically what the Angular linker is trying to do. And this approach allows us to offer the stability and compatibility of libraries as we have been able to do before. So you ship it in partial compilation mode today, and then the compiler or the Angular compiler is still able to understand that partial declarations in next year, for instance. And this enables faster builds and easier caching because it all operates on individual source files. And another benefit is now that libraries can actually start leveraging all of the Ivy compilers improvements that I've shipped over the past 2 years, where it is able to offer much better compilation errors compared to View Engine. And also application builds no longer have to use the metadata.json system that I mentioned, which was actually kind of hard to produce good errors from, whereas this system doesn't have that problem anymore, because the AOT compiler is basically ran during the library, when the library is actually built into partial compilation. And this approach allows us to still evolve Angular and its template syntax, for instance, in the coming years to improve whenever we see the fit or whenever we find new or better ways to do something, while not breaking libraries that are already out there somewhere. So then you might wonder, how do I actually start using this? And it's fairly simple, luckily. There is this tsconfig lib prod JSON file. It is in the library root, and it used to contain enable Ivy false because, as I mentioned before, libraries were still built with UEngine before v12. And if you have an existing library, then you can now switch or basically remove this enable Ivy flag, so to start using Ivy, and then enable partial compilation mode by setting the appropriate flag. And then when you rebuild your library, it will have used the Ivy format and the Ivy compiler to build your library. And you also will no longer have the metadata.json file in place. If you generate a library with Angular 12 today, then this is the default already. So partial compilation mode is the default, and you won't even have to do this. A last thing to mention is that if you go this route, if you choose to go this route today, that's great. It offers great benefits, as I mentioned, but it does mean that your library can only be used in Angular 12 when Ivy is used. So you can no longer use that in Angular 11, for instance, if you wanted your library to be compatible with 11. You cannot enable this system. And that's it from me. So I wanted to give it back to the folks over at, well, all over Europe, I think.
Very, very interesting stuff, Joost. Also, it's great to see that we just use ng generate library, and under the hood, a lot of stuff happens. So let's move on to some questions. But I think, Alex, Joost is not in the panel.
I'm not sure if
Something happened.
Yeah, if his connection dropped.
All right, let's proceed, and then he joins again.
Oh, I think he's back now.
Oh, sorry, I was muted. There is Joost again.
I was a bit enthusiastic with closing windows, I think.
Yeah.
Close
I just wanted to say something about Joost, because somewhere in the middle of the presentation, he said that his brain was freezed and he skipped a slide, but I just read a comment in one of the YouTube channels that says that we need more Joost in Angular meetups.
Nice. I still don't know what it said, so let's just forget about it ever happened.
Well, Joost, dankjewel.
Graag gedaan.
Which means is thank you in Dutch for your talk. We have some questions from the community. I have some questions, and I think we will go over those now. I think one of the first questions I saw was what the heck is an evergreen browser? And I think Minko can.
Sure. Yeah, we have been using the concept of evergreenness as software that can keep up to date with updates, so receiving updates over time. For example, in Chrome, you're getting these auto updates. Same in Firefox, I believe, like Safari and all the modern browsers, but IE 11. Edge, including, it's an evergreen browser as well. And we have been trying to apply the same for Angular so that we can keep everyone up to date with the latest features and improvements we do in the framework.
Okay. So Safari is an evergreen browser?
Should be, yeah. It's updates together with your operating system.
Yeah, it upgrades with your operating system. It's still not supporting everything.
Yeah.
It should, though. Okay, up to the next question. I think most of the questions are about building libraries. If you're building a library for internal use, do you need the linker or can you just use it as is?
That's a great question. And as usual, the answer is always it depends. Because you have to make sure if you don't want to use partial compilation mode and just use the Ivy compiler to build fully AOT compiled code, that is possible. And you can keep that internal in some sort of registry. But then you need to be aware that whenever you use that library in an application, that it uses the exact same Angular version. Because as soon as the versions start to misalign, then you may run into weird errors.
So if you have everything in a mono repo, you're good to go.
Yes, that's true.
I had a second question, which is basically the same question with different words. When will the API of the partial decorators, the partial linker, go public? Is it going public? Or is it a closed API?
So there's probably a difference between public API and stable API, where we shipped it in 12 as stable API, which means that you can rely on publishing a library today, and then it will still be supported in the next 2 Angular major versions, at least. Because that's basically our compatibility guarantee that we provide for libraries. We don't expect you to alter these declarations yourself. So it's not public in that respect, that we expect you to write this code and then ship it to NPM and then let our compiler deal with it.
So we cannot use it for dynamic instantiated components.
That's not how it's currently meant to be used, indeed.
I see an opening there. Another question, a little bit more lighthearted for both Minko and Joost. What is the biggest thing, future / whatever, you're looking for in version 13, 14, 15?
I'll leave that to Minko.
So I'm excited about optional ng modules. This is something that will land. We cannot commit to a particular version, but this is something we started looking into. Actually, with Joost and a couple of other folks, we've been having design meetings talking about it.
Yeah, that's actually a surprising topic, because it is everyone remembers, or who is familiar with this concept remembers Minko's pull request from 1.5 or 2 years ago or something, where he added kind of this idea of optional ng modules just casually in a PR. And then we are now actually talking about how this would all fit together, and then you start to realize all additional concerns that you need to take into account, which were probably not have been thought out in Minko's PR 2 years ago. It's a lot harder of a problem than you would initially think it is.
Yeah, I went ahead with the original implementation in RC4 of Angular 2.
Cool. Also, I had a question about someone asking about a Clover engine.
Yeah, it's an Angular Universal thing that is experimental right now. We're trying to switch our server-side, not switch, but just to experiment with using JS DOM rather than Domino, which could potentially just get rid of entire class of errors. But this is just a very early experiment still that the Angular Universal team has been just looking into.
Okay. I think the other panelists had a couple of questions.
Yeah, just wanted to mention a comment that I saw in the YouTube about libraries. It is from the Malaya, and it says NX libraries are somehow easier to work than Angular libraries. And I would like to ask you if there is a difference if you create a library in a monorepo And if you create it just just make a new folder inside your Angular CLI workspace and import the library from there. And I have also seen a tweet from Igor Minar the last weeks stating that secondary entry points for Angular libraries are way better than using monorepos. Especially when all the libraries and applications on your monorepo have the same exact Angular version. What's your thoughts on that, Joost?
So in a monorepo, probably every library is sort of like an entry point, right? Because you don't have to, there's no publishing aspect in a monorepo. And the publishing aspect is really about the package level, the package boundary that you define. And as I mentioned, you can have multiple entry points in a package. But if you have a monorepo, then basically all of your monorepo makes up a single package with all of the different entry points. And I can go into a bit of detail about how NX libraries are sort of different and also sort of similar to what I just presented. Where NX sort of cheats out of the box, where a library, an NX library, is still compiled as part of the project that you serve. So if you have an application in NX and you refer to a library that's also in your NX project, then it will incorporate all of the TypeScript files of the library into the compilation unit of the application. So you have to also build all of these TypeScript files when building the application. And that offers a great user experience, of course, because you don't actually have to reason about all of these library boundaries. So that's why they are typically considered easier. But you do end up with also like this, it's less powerful in the sense that you get a bigger compilation unit. They do have an alternative for that strategy, which they call buildable libraries. That might be new in a more recent version of NX. And then you do end up actually publishing or generating, compiling a library separately into a dist folder, and then consuming that library from within the dist folder. And then you start to see, that's basically what the CLI is doing as well. So what the CLI is doing is also supported in the CLI, and there's trade-offs as usual in this approach.
So if I have, for example, two Angular applications separate from one and the other, and I have built a library, but I don't want to create a monorepo, can I just import the library into the VS Code workspace, and when I build my application, it will also import and build the library?
I'm not sure how to interpret that.
Yeah, for example, you have your application, and in another folder in your file system, you have your library, but you don't want to have them in the same repo. So what you do, you add into the Visual Studio Code workspace the folder of your Angular library.
Okay. So I showed you how the path mappings can be set up.
Yeah.
And you can set up your path mappings to point into whatever file system directory there exists. However, there's a big catch, because you have all of the dependencies from your application build. So for instance, you are using TypeScript 4.2 in your application, but your library is still authored using TypeScript 4.1, because of course it has its own package JSON and its own dependency specification there. But now if you start to just get all the files from that separate file system directory, then you start to use the dependencies of your application, and this may start to become incompatible very quickly. And that's where in a monorepo typically you would only have a single version of everything, where you have a single specification of all your dependencies, for instance. And then this problem is in there.
Cool, thanks.
We have another community question, which is it possible to nest libraries? I'm not sure who wants to take this.
how should I interpret nesting in this sense?
Maybe composition?
We have this question, so it's possible to nest libraries, and I think indeed it's about composition, like, okay, I'm going to gather like a couple of libraries and export it as one bigger library. I think that is the question. Did we get it right? Not seeing anything in the chat just yet. If there comes an update, I will update the question.
Yeah.
There is another question. Well, it's in kind of two comments, but is from Jimmy. He says, so far we've been able to, so he has problems with the memory limit for builds. And yeah, he's wondering, so far he's increased the amount of memory, but that has its limits. And the question, yeah, is any advice on how to improve the build performance?
Oh, so this is a very complicated question in terms of there's a lot of things at play when you build an application. And splitting it up, splitting your libraries into multiple compilation units mostly helps with your TypeScript build, and it's type checking because it has fewer files to type check and then to emit into JavaScript. So in this respect, it helps to have multiple libraries that are smaller. But if you build it into an application, then currently the tooling that the CLI uses is Webpack, and Webpack needs to take all of those JavaScript bundles and run like optimizers such as Cursor and stuff on top of that, on all of these bundles. And then having split it out into multiple libraries doesn't help you, because you still end up with all of these bundles together and then having to be processed by an optimizer. So if the memory limits you're looking at are caused by optimizers, for instance, then splitting it up in libraries won't help. If, on the other hand, you're seeing memory limitations or CPU-bound limitations in terms of TypeScript processing, then it would help. But so, as I said, it depends on kind of where the resource limits are.
Okay, thank you. I think we have a comment for the previous answer now, which I think it was what, yeah, mixing libraries inside another library or using.
So that's perfectly fine. And a typical example is how Angular Common, for instance, also uses Angular Core, and how Angular Material uses Angular Common. So those are all just libraries depending on each other. That's not a problem.
All right, I have another question, not related to particularly to today's talks. Is mainly about the Angular material, and I know there's the material experimental components, which they're using the MDC CSS. Is there any timeline, or when would those experimental components actually become the new components?
Yeah, we're expecting to release this sometime this year.
Ah, that's cool. Awesome. Nice. Thank you.
Nothing new. I just wanted to ask Minko a more general question about, we have already seen what you can do with Angular. You can build PWA applications like Spotify. You can build desktop applications with Electron. You can build mobile applications, all that stuff. And Ivy has truly enabled all these interactions. What's coming next after Angular 12 about compilers?
About compilers, probably Joost would be able to talk more about this, but generally we are not planning to rewrite Angular or make anything crazy. We're planning to just incrementally continue improving it. And there are going to be different paths of the story, like different parts. For example, optional ng modules, as I mentioned already, optional Zone.js, and before that, maybe even allowing you to compile your output to ES 2017 so that we can handle properly async await, just like such small incremental projects where we maybe potentially hydration, we'll see. That's kind of one of the questions that we cannot answer just yet, but it's something that we're interested in as well.
I would be interested in that too.
Yeah, many people. Me too.
I think I've found a way though, but that's outside of the scope of here.
We have been looking also at improving the content projection. When I started talking about hydration, I felt the pain of content projection for some reason. So we are thinking of improving it too. There is a very highly requested issue in Angular framework, probably the second most highly requested one, which is for dynamic content projection, I believe. And this is something on the roadmap. We haven't shared it publicly just yet because we haven't started working on it, but there are plans for improving it too.
Are there any plans to speed up the tool set for big applications? Any things on the roadmap where you say, hey, that might be a noticeable bump in compilation speed or compile speed, build speed?
Yeah, we have been investigating micro frontends, and part of this is just modularization of your large application so that you can compile different independent units separately and have faster build times. But generally, I think like just practically, compilation has its physical constraints. When your application gets certain size, we need to parse it still. We need to process it, and at a certain point, we hit certain like limits of the hardware. So we're constrained by this, unfortunately. And just modularization, I guess, is the way to move forward after certain threshold. And yeah, Joost can comment also on this because that's one of his areas.
Yeah, I'm very enthusiastic, that's a hard word, about performance, and especially in the compiler. And I've done a lot of profiling over the past year since IB became the default, and we've made great progress in optimizing kind of the analysis pipeline of the compiler itself. But also, for instance, the compiler does template type checking, and in order to do so, it generates TypeScript code. And the TypeScript code itself that it generates, it's sort of hard on TypeScript with all of its flow typing capabilities. And we have hit several TypeScript bugs where our generated template type checking code would generate very expensive to check TypeScript scenarios. So we fixed a couple bugs in TypeScript itself to optimize this, and also we looked into how to generate slightly different or just less template type checking code in order to reduce the strain on TypeScript when it is actually type checking your templates. And sometimes this became like 10 times faster, where template type checking used to be 30 seconds, for instance, and then I managed to get it down to 5. So stuff like that is still going on, where we actively look into these performance limitations.
Yeah, I've noticed that that the types are way faster with version 12, but the Angular compilation is only like a small part of the whole tool chain. And I think most of the pain is in TypeScript itself and then Webpack. That might just be my...
Yeah, so what we regularly see in builds, in development builds, source mapping is generally quite expensive. That's driven by Webpack. For production builds, the largest overhead comes from optimizers. So they shuffle around your code, do several passes in order to get the smallest payload size possible. But as such, they're also quite intensive on your CPU. That's where most time is spent in this case.
Yeah, I don't really mind the production build. It is mostly the ng-serve and those kinds of things that are most important to developers, I think. Although ng build time for production is also important if you have like a couple of pipelines that need to do like 5 or 6 different builds to test everything. It quickly adds up. You end up with pipelines that take like half an hour to 50 minutes to go for one build, one complete build, which is a little bit of a pain in the butt. Michael Kurt is saying it sounds like ng include is being considered. And I think Michiel should say a little bit more what he means, but I have a fair guess.
I don't know.
I don't know either.
I think ng include is loading templates dynamically.
Well, we are thinking about like some composition APIs. So we have been thinking about potentially considering dropping JIT if not dropping. Let's say asking the community if JIT is important, because JIT that's yet another compiler that we need to maintain that like compile stuff at runtime. And in order to make sure that we have complete compatibility between, like we have the same semantics between JIT and AOT. I guess theoretically it's like not even possible, but just to keep it as close as possible, it's a lot of work on our side. And in order to make sure that we still provide dynamic behavior and you're able to compose, like build components on demand, like dynamically in the browser, rather than using JIT, we're thinking of providing like some kind of a composition API, but that's far ahead. We still need to run an RFC and collect feedback about JIT from folks, which should probably happen in the next couple of months. And from there, we're going to keep it open for a while and decide how we can move forward with it.
That is cool. Also, I have a question about using component factory resolver. With Ivy, this should not be necessary anymore, but still you cannot build an Angular application without it if you need the dynamic stuff right now.
Yeah, it does almost nothing, right? Just for Ivy, I mean.
Yeah, that's true. So there have been recent discussions on, so for instance, there is like dynamically creating a component now requires such a factory. So you have to then actually get the resolver in order to obtain the factory. Those APIs are all centered around the view engine concept, so Ivy doesn't necessarily need them. And we have been exploring actually just getting rid of those concepts, at least for Ivy, to work on the component class itself. And we are currently hesitant to go that route at the moment. Primarily because Google internally still has some view engine apps. And whenever we start adding these Ivy-specific features, it becomes very hard on Google's side to manage this appropriately, where it becomes problematic for teams how to do with documentation, the Ivy-specific features. So we're holding out on that for now.
I would say Google has deep pockets and enough engineers to fix this, so...
So the fix is that the rollout to Ivy is continuing to be dealt with, and eventually it's all Ivy.
Good. So we need to wait until View Engine dies inside of Google before we can have like nice things without component factory resolver.
For now, yeah, maybe it doesn't have to be completely dead. But, yeah.
Okay. I don't think we have any more questions. Michael Kickert is saying, heard something about dynamic template inclusion, which is in the same vein, I think.
I'm not familiar with this.
Yeah, I didn't hear about it either, but... So he didn't hear it from me. Okay. That was about it. I think we can round off. I don't think we have any more questions. Do any of the other panelists still have a question left?
Oh, if you have questions also, you can reach out to us on social media. We are available and we'll be happy to chat.
We know.
Sure.
Yeah, so thank you both for your time answering all the questions, and also for the two great speeches.
Okay. We still have one question, and I think that's an interesting one for Minko. The question from Tepmalia. Curious if Google uses another framework for any project.
Yeah, we have a couple of frameworks in Google. So the two major frameworks are Angular and Wiz. Wiz is a sibling team. They're really great in terms of load time performance, really great. But at the same time, it's kind of not very ergonomic to create applications with Wiz, because you need to configure a lot of things so that you can get this performance. And sometimes this could be kind of you're over optimizing from the beginning. So if you're not building Google search for a couple of billions of users, it might not be worth it to go with Wiz. In some cases, it might be very much worth it, like building Google Photos as well. So we have these two main frameworks that are being used within the company, and there are different guidelines for which you should pick one or the other. There is also Flutter Web. Flutter Web is primarily used when you have a solid mobile experience, and in some cases you want to have also a web experience without rewriting your application from scratch. In these cases, there are a couple of applications in Google that are using Flutter Web. Vue and React, there are some open source projects from Google that are using some of them, but generally they're not widely supported in Google because, for example, when you introduce a new technology in Google, you need to take the responsibility to maintain it. Like we are maintaining Google, and we're spending a lot of time on making sure that all applications in Google built with Angular after every new release, after every couple of new commits, actually. And to take this same with TypeScript, to take this responsibility for Vue and React, you have to have a team of like maybe 10 people dedicated to just support these frameworks within Google. And since Vue and React and Angular, although they are slightly different and so slightly different use cases, their feature set like overlaps to a big extent. And Angular is a more opinionated framework. It is a good fit for scalable applications within Google.
That's awesome, Minko. That's a lot of information in this answer. I think we need to wrap up because we're out of time. Today we heard some interesting talks. We would like to thank the Angular team for their time to come in our joint meetup and talk. And also, I would like to thank Sander from Angular Dutch, Alex from Angular Birmingham, and Yanis for his assistance from Angular Athens. We hope we will see you again in another joint meetup. And have a nice day. Bye.
Bye-bye.